Hello everyone, today we are going to talk about the key takeaways from chapter 3 of Headfirst, Know Your Variables. So the key takeaways from this chapter are actually what variables are and then the two types of variables, primitive variables and object references. So let's go through them. So what are variables in Java? So variables are like cups or containers and they hold something and they can hold two types of these things. One of them are called primitives and another one is called object references. Primitives hold fundamental values like integers, booleans and floats, and object references actually holds references to objects. And these variables have a name and a type, and as far as name is concerned there are rules in which you can name them. So it should not start with a number. It should start with either underscore, dollar, or any letter. After the first letter, we can use numbers. First letter variable can't be number. And any name that follows, there are two rules. And as long as it does not use Java's some reserved keywords like public, private, final, protected, so on, we are fine. So that's variable. So and as we said, there are two types of variable. One is primitive variable and another one is object references. So let's go through the primitive variable. So primitive variables come in different shapes and sizes and has a fixed number of bits, and based on these sizes they have different names. So if I talk about some numerics, so you have byte, short, integer and long. Byte will have the size of 1 byte, and short will have size of 2 bytes, and long will have 8 bytes, and integer will have 4 bytes. So that was primitive and the sizes that they come in. So there's something that I want to talk about primitives is that, let's say you want to assign a large variable into a small variable. It won't be allowed in Java. So if we take this example, let's say we initialize one variable integer x and gave value 24 to it, and let's say we want to assign this x to a variable which is smaller in size, byte. So this will not compile. But what about the other way around? Let's say we had a variable byte with something and we wanted to assign it to a larger variable rather than a smaller one. Let's say int. Will that compile? Yes, that will compile. So if you see this example, we define byte b is equal to 24 and then we assign this byte to integer. This will compile all right. So the reason it does not allow values from large variables into small variables, because there's a possibility of spilling, right? You can have int with a value. 24 is a small value. Even byte can store that value. Let's say 20 int x has a value which can't be stored in byte. In that case, there will be possibility of spilling. That's why Java does not take that risk and does not allow you to assign large variables into smaller ones. So staying with primitive, so there are 8 types of primitive variables in Java. I have listed them with their sizes and value. So let's go through them. The first one is Boolean. The size of Boolean is actually JVM specific. The value is either true or false. Then you have char. Char is actually 2 bytes, which is same as 16 bits, and they will go from 0 to 65,000. And then you have byte, which is 8 bits. So this will go from minus 2 raised to the power 7 to 2 raised to the 7 minus 1. And then you have short, which is 2 byte or 16 bits. This will go from minus 2 raised to the power 15 to 2 raised to the 15 minus 1. And then similarly bits and long. Similarly int, sorry, not bits, int, which is of size 4 byte or 32 bits. This will again go to minus 2 raised to the 31 to 2 raised to the 31 minus 1. Similarly long, which is of 64 bits, will go from minus 2 raised to the power 63 to 2 raised to the power 63 minus 1. And then you have float and doubles. Float is of 4 byte and double is of 8 byte, and their range kind of varies. So there's one thing that I want to talk about is you have long and int, right? How do you differentiate when you assign a value to a variable? What is long and what is int? The way you do it with this letter L, it could be either uppercase or lowercase. So whenever you define long something, then you assign a value, then you append that value with the either lowercase l or uppercase l. Similarly, in case of float and double, that's how you differentiate. In case of float, you use letter F. Again, you can use small f or capital F. It's up to you. But this is how the compiler differentiates between integer and long and float and double. So that was primitive. Now let's talk about object reference. So there's a misconception that there's object variable, but there's no such thing as object variable in Java. There's only object reference variable. So what do we mean by that? So object reference variables hold bits that represent a way to access the objects on the garbage collectible heap. It does not hold the object itself. It just represents a way to access the objects on the heap. So we can think that it holds something like address or a pointer using which the JVM can access the objects on the heap. And it represents only one object at a time. So if we differentiate between a primitive variable and object reference variable. So primitive reference variables hold bits that represent the actual value of the variable itself, whereas object reference variables will hold bits that represents a way to access the object on the heap. That's the difference between primitive variable and object reference variable. So we can visualize object reference variables like remote control. Sorry, just like pressing a button on remote control, you can make uh, just when you press a button on remote control for TV does something, right? Either you increase volume or decrease volume. Similarly, you can use the dot operator or reference variable to either invoke method or to access an instance variable. So one of the ways you can, let's say, invoke a method bark on the object my dog is using this dot operator. So there's something called final object references. So let's say you defined object reference and you marked it as final. So what happens is it cannot be reassigned to any other object. That's what final means. So we also have null object references, as in let's say you created one variable of any object and you assign null to it. It means that it is not representing any object on the heap. So if this was not clear, I'm sure things will get clear with these pictures. So these pictures are straight from the books. So let's say you defined and created two objects, book B, and you assign it an object, and then you create another variable, book C, and then you assign it one more object. So whenever you do this, okay, let's say you just declared book B. So you have created one variable, okay, and then when you create book, you have created one object on the heap. When you assign these two things, you have in a way linked this variable to this object on the heap. So now this particular variable hold the bits that represents a way to access this object on the heap. Similarly, again, book C, you have defined a variable. With new book, you have created an object on the heap, and when you assigned, now you have linked this particular variable to the object on the heap. So this is the state of things. You have two objects on the heap, you have two variables, and they are all pointing to their respective objects. Let's say you created another variable book D. Okay, you define another variable book D. Now rather than creating any new object, what you did, you just assigned the already existing reference variable C. Now this particular variable book D will hold the same bits as C. Now C represents a way to access the object on this heap, which is marked as 2. So this particular variable will also hold the bits that will represent a way to access this particular object, which is marked as 2. So this is how things would look like. You already had a variable B linking to the object marked as 1, and then you had variable c pointing to the object marked as 2 on heap. Then we created another variable d, and then we assigned whatever was in c. So d will also be pointing to this particular object, the same object marked as 2. Let's say now what we did, now we are assigning b to c. So whatever the bits that variable b was holding, c will now hold the same bits. So b earlier was holding the bits that represented a way to access the object marked as 1. So now c will also hold the bits that will represent a way to access the object marked as 1. So this is how now things would look like. Earlier it was pointing to object 2, but now this will point to object 1 after this assignment. So this was this. Let's see another set of examples now using variables. Let's say we have created again two variables, book B and C, and then we assign two objects to them on the heap. So this is how things would look like. We'll have two active references. By active reference I mean the reference which is pointing to an object on the heap, and then we have two live objects, two reachable objects. By reachable I mean there's a way, there's a variable through which we can access those objects on the heap. That's why they are reachable. Let's say we assign B to C. Okay, these were two variables. Now C was holding the bits representing a way to access object marked as 2. Now B will, after assigning C to B, B will hold the same bits as the variable C. So in that case B will also point to the object marked as 2. Okay, so this is how things will look like. If you see, there's no active reference pointing to this particular object marked as 1. So this object is actually unreachable. The moment any object becomes unreachable on the heap, it is eligible for something called garbage collection. Okay, so right now in this state of things we have two active references, okay, these, and one reachable object and another unreachable object or abandoned object or object eligible for garbage collection. Let's say we assign C to null. Now the moment we assign C to null, it is not representing anything, it is not pointing to any object. So this is how things would look like. So B will be our active reference, C will be a null reference, it is not pointing to anything. This one is still unreachable and hence eligible for garbage collection, but this guy is still reachable through this particular variable B. So it is not eligible for garbage collection yet because it is reachable. Okay, so that was the objects and object variables. Let's talk about arrays. What kind of variables they are whenever we define arrays. So arrays are always objects whenever they are defined, whether they are declared to hold primitives or object reference, it doesn't matter. They are always objects, and every element in the array is just a variable. Okay, these are two important things. One is they are always objects whether they hold primitives or object references, and every element in the array is a variable itself, and those variables could be primitive or object references. If they are primitives, they will hold the value itself, and if they are object references, they will hold ways or address or pointer or bits that will represent a way to access the object on the heap. So let's say we define this particular array int nums is equal to new int. Okay, this is an array that has been defined to hold primitives int. Okay, how things would look like in heap and JVM. So what you have defined is this nums is actually a variable. Okay, because arrays are objects, there is no such thing as object variables. Okay, this num is actually an object reference, a reference to refer this array object on the heap. Okay, so this is what you see. You have this nums, an array, an object reference variable that represents a way to access this array object on the heap. And as I said, every element in the array is just a variable. So this is, it has 7 elements and all of them hold primitive values. Okay, So you have array of 7 primitive variables. So all of these, let's say, variables will hold int values. Okay. So another way of looking at this array, if you consider variable as a cup or a container, you can imagine array as a uh, tray of cups. Okay. So this was an array declared to hold primitives. Let's see how arrays declared to hold object references would look like. Let's say, yeah, let's say you defined, let's say you defined, let's say you have a class or object dog, and you have defined an array of dogs which hold 7 dog object references. So this array dogs is actually your variable, which represents a way to access the dog array, which is an object of 7 uh, object reference variables. So remember, every array, irrespective of whether it holds primitives or object references, is an object. That's why it is on a heap. Now every element in that array is a variable. In this case, it happens to be a reference variable because it is holding object reference. So all of these containers will be holding object reference variables, not the object itself. Okay. So when you define this, all you have is one object reference variable for this array, and then every element of this array again holding object reference variable to different objects on the heap. So we don't have the individual objects yet. Let's say, and again you can access these reference variables using uh, using these symbols that you use in array. So using index 0, you can access the first object reference variable, and then when you create new object, this new dog, this will create another object on the heap, and using assignment, now this particular reference variable will be pointing to an object on the heap. Similarly, using docs1, we will be making this particular object reference variable pointing to another dog object that we are creating. Okay. And yeah, this is how things would look like after we have created these two objects. Then these object reference variables will be pointing to those objects on the heap. So how do you access, let's say, this particular dog object, because all you have is this dogs, right? So using this 0 1 and all, you will go to these elements, and then using dot operator you can access the instance variables and the methods. So in order to summarize, arrays are always objects. It doesn't matter whether they are defined to hold primitives or object reference variables. And because they are objects, they are on the heap, right? There is no such thing as object variables. So what you will have is object reference variable. So whenever you define array, so whatever you have named that particular array, that name is actually an object reference variable pointing to that array object on the heap. And the second important thing about arrays is every element in the array is a variable. And again, that variable could be the primitive variable or object reference variable. When variable is primitive, it is holding the actual value itself. Okay. And when it is a reference variable, it is holding a way to access the objects on the heap. That's what you see. So if you go back to this, in this particular case, when we had an array defined to hold primitives, the actual values was in these containers or variables itself. When we defined an array of object references, in those cases, these object references were just a way to access the object on the heap. So that's it, guys, for chapter 3. See you in chapter 4.